In this video, I'll demonstrate how to take the derivative of a set of parametric equations, and I'll show that derivative in both the parametric form and in the Cartesian form. The Cartesian form just has the x and the y. The parametric form has the t involved as well. Here we have, consider a particle whose position in meters is given by the parametric equations x equals 2t and y equals 4t squared minus 5, where t is in seconds. So just a little background here. The x would be the horizontal form, or the horizontal part of the particle's position at any time t, and t is in seconds. And then y would be the vertical component of the particle's position. So it's going across and it's going up and down, and it'll trace some path like that. Not exactly like that, but it traces some path. It doesn't just go left, right, and up, down one at a time. It goes both up and down and left and right at the same time, but we've broken it up into two different parts. Okay, so let's first understand how we take the derivative. And we're going to just use this rule. There's some neat math behind it, but we're going to use this rule that if we want to take the first derivative, dy dx, and we're going to need that first derivative to find the instantaneous velocity. The instantaneous velocity is the dy dx of the particle at time equals 2 seconds. So dy dx, the first derivative, is the instantaneous velocity, and we'll use this rule. That equals dy dt, so the derivative of y in terms of t, over, you guessed it, dx dt. So the derivative of x in terms of t. I'm going to do the derivative of y first, just because that's what we have listed first. So I've got dy dt, let's make this y more apparent, dy dt, and that equals 4t squared minus 5. The derivative of that with respect to t is 8t. The negative 5, the derivative of negative 5 is just 0, so we've got that. The next derivative, dx dt, the derivative of 2t with respect to t is just 2. So there we have it. We've got the derivative of y and x in terms of t, or with respect to t. Let's put those together and find the dy dx. Dy dx is the first one, the 8t, divided by the derivative of x. That's 2. So that would equal 4t. I'll take one last step to simplify that. We get 4t. That is in parametric form. Now we want to find it. What is the instantaneous velocity when t equals 2 seconds? Well, let's just plug it in there. We've got dy dx equals 4 times 2, because we're plugging in 2 here for t. So the instantaneous velocity is 8, and our label is meters per second, because that's how the problem is defined, 8 meters per second. Now, if I wanted to take this parametric form and put it into the Cartesian form, just real quickly, all I'd have to do is substitute in for t some form of x. So what do we have here? We have a relationship between x and t. We have x equals 2t, so therefore t equals x over 2. T equals x over 2. So I'm going to plug in x over 2 wherever I see a t. So another way of writing dy dx, the first derivative, this is just in terms of x and not t, is 4 times x over 2. So therefore, let's simplify that. We've got dy dx equals 2x. Okay, that's the Cartesian form. And over in green is the parametric form of the first derivative. Now, so this is saying what is the change instantaneous change in velocity with respect to x. So when the particle is at any given x or horizontal position, we can find the instantaneous velocity, whereas the parametric says at any given time t, we could find the instantaneous velocity. Okay, find the times when the horizontal and vertical components of the particle's velocities are equal. Particle's velocity, not velocities. It's just the two different components of the particle's velocity. All right, all we have to do is set these equal to each other, because each of those are the velocity of the instantaneous velocities in the horizontal and vertical components, as we talked about up here. So let's just set those equal to each other real quickly. We've got 8t, that's the vertical component of the particle's velocity. When does that equal? At what time t does that equal the horizontal? That's dx dt. There's 2. Solving for t equals 1/4 of a second, and it's really just one time, not times. So at 1/4 second, that is when the particle is going just as fast horizontally as it is vertically.